Completing the square when there's an odd coefficient in front of the x term. Everything is the same, except that you are going to be working with fractions. And try to keep the fraction the same all the way through. The first term stays, so does the second. The last term, just chuck it on the end. Right, as usual, take the number part, which is just the 5 divided by 2 squared. Of course, if you add it in, you must also subtract it out. Now the perfect square is actually just whatever is inside the bracket, including if there was a negative sign. It would just be x plus 512 all squared. But then you must evaluate the second one. So you square the top, square the bottom. It will be 25 on 4. Of course, when you add or subtract fractions, you must have a common denominator. Change this to a denominator of 4. And the last step would therefore just be you stop there if you want it in turning point form. If you wanted to factorize it fully, then you use dots. And when you square root this, remember the denominator becomes 2 and the numerator stays at root 29. Okay? If you were to do that, it would be x plus. And then the minus 1, which minus present here. If there's a coefficient in the x squared term, you must actually factorize that out right from the start. So you're working with lots of big fractions already. Right? So then it becomes but everything else is the same. If you divide a fraction by 2, actually all you do is just simply multiply the denominator by 2. So instead of being 4/3, it becomes 4 on 6, which is 2 on 3. Everything else is the same. Now because we're going to have brackets inside brackets, these ones here, I like to use square brackets for the outside. Alright, so then the 3 stays. This becomes a square bracket. The x squared is still there. 4 on 3, x. Put the negative 1/3 over to the other side. That bracket becomes a square bracket. Now, you're adding the new term, as I was saying, the number part, right? The 4 on 3. You divide that by 2, which means you multiply the 3 by 2, which actually simplifies to just negative 2 on 3, and then squared. And if you add it in, you must also subtract it out. Right? Then, the perfect square, as I said, is the x term with this number in here, including the sign. The 3 is still there, the square brackets are still there, but now we have a perfect square bracket. So it'll be x minus 2 on 3 all squared. Evaluate this one. When you square the negative, it becomes positive, but then you apply the negative, so it's still negative. 4 over 9 minus. Combine the last two terms together. Right, you cannot leave it like that with the square brackets. So what you need to do is you just need to expand back the 3 into only the second term, but leave it in front of the bracket. So it'll be 3 with the bracket, but multiplying into the second one, the 3 cancels with the 9, just becomes negative 7 over